There is some problem there. Yeah. So yeah, there is a need for irrigation. Water is increasing, so there is a potential to increase the productivity. Therefore, a web-based tool has been developed for variable rate irrigation in Southern California. Variable rate irrigation is the ability to vary water application every few meters across a field to address specific soil and crop conditions. Dr. Hagwadi already talked about this VRI in details. So if we see this figure here, here the field is divided into four areas or four subregions based on the soil properties. So if there is a possibility that we can apply irrigation in these areas at variable rate to increase the productivity. All the agricultural fields, here we can see of all the fields of Imperial County are selected as the study area for this study, and Landsat 8 satellite data acquired on 5th July 2020 has been downloaded and selected for this study. Drone data can also be used. My limit Anish just presented a nice presentation on the uses of drone data, but the drone data is not available for all the fields at large scale, and we do not have access to farming data. On the other hand, Landsat satellite data is freely available. It covers a larger area and everyone can use it, and it is frequently available, that is every 16 days. That's why we are using Landsat satellite data for this study. As you must be aware that Imperial County is an agricultural hub which consists of a variety of crops, and it uses most of the water, that is 58% of the total water allocated to Southern California. That's why there is a need of variable rate irrigation. Southern California desert agricultural systems are mainly driven by irrigation. Also, it is important to address the within field variability or heterogeneity within the field while optimizing water use by considering variable rate irrigation. Satellite images have significantly reduced the cost, time, and efforts spent in collecting the data from the field. Therefore, by using this VRI-EVAL tool, growers would be able to determine the optimum number and location of management zones within the field. Management zones are the subregion of a field that are relatively homogeneous with respect to soil or crop attributes. Here, if we see this figure again, here the field is divided into four areas or subregions based on soil properties. So these areas are called as management zones. The field can be divided or delineated into management zones, mostly using various parameters like yield maps, soil and topographic properties, electrical conductivity, remote sensing based vegetation indices, and the combination of these properties, which could be related to the soil or crop parameters. Basically, we are looking for variability in the soil within the field. So generally, management zones less than 10 are preferred because we want to keep the system as simple as possible while optimizing the water use. This tool uses satellite-based crop index Ndvi and grouping or clustering techniques, which can group the divide and then group the field into natural groups based on variability within the field. It will help growers in optimally dividing the fields into irrigation management zones. For this purpose, multiple fields in Southern California with substantial variability are selected as study areas to conduct experiments and pre-adoption assessment of the tool. So the main objective of this study is to develop a web-based tool, a variable rate irrigation pre-adoption assessment tool, VRI-EVAL, for variable rate irrigation in Southern California using satellite data. These are the various steps involved in the process of development of VRI-EVAL. First of all, satellite images are downloaded online to compute the Ndvi index for around 7,000 fields of Imperial County. Then this Ndvi index, Ndvi data obtained is cleaned to remove the outliers present in the data, and then the data is clustered into 2 to 10 zones. Now we want to know the optimum number of zones out of 2 to 10 zones. So for that purpose, performance is evaluated for each of the zone to compute the optimum number of zones. Once all these steps are followed and repeated for each and every field. Once all the results are generated, these all are combined together into VRI-EVAL. The VRI-EVAL tool, it collects all the outcomes and information on the single screen and converts the data into picture or graphical format, which is easy to visualize, access, and easy to understand. In this tool, Ndvi, normalized difference vegetation index is utilized because, uh, because there is an assumption that the variability in soil within the field is related to the plant health, and Ndvi is a good indicator of plant health. That's why Ndvi is used for this study. It actually ranges between -1 to +1, depending on which part of the fields have dense, moderate, or sparse vegetation. It is actually a measure of the state of plant health. When the value is close to 1, it indicates the healthy plant. And when the value is close to 0, it indicates bare soil areas or the sparse vegetation areas. And it is computed using near infrared and red bands of the satellite data. So now for better understanding of the tool, I am going to explain the results for one of the fields which is randomly selected. Here I have performance graph with number of zones shown on x-axis varying from 1 to 10 and within zone variance increasing from 0 to 100% on the y-axis. So using this graph based on our criteria, the optimum number of zones are obtained as 4 for this particular field. That's why this field is divided into 4 zones, which you can see are represented by 4 different colors, which are represented by red, yellow, light green, and dark green colors. These are the 4 different management zones where irrigation may be applied at variable rate to enhance the productivity. Here, this scale indicates the average NDVI value for each of the 4 zones. Here, red areas have value of zero point 0.4, which is a lesser value. So, which indicates NDVI, like plant health is plant is not relatively healthy as compared to dark green areas. In dark green areas, value is relatively higher, which indicates the plants are healthy. So maybe, yeah, maybe more water can be applied here. So now moving on to VRI-EVAL web-based tool. Here, I am showing you the screenshot of the home page of the VRI tool. It consists of various elements. Here, this is the Google Earth imagery or map, which is showing you all the fields of interest, which are highlighted in yellow color. Here we have search icon. If you know the location of your field, then you can search using this icon. And this is the home icon to go to the home page. And we have zoom in and zoom out options. The next element is a gauge showing you the statistics of Ndvi. These are the random numbers which are used to indicate the variability within the field. Like for this particular field, random field, it is showing that the Ndvi is varying from 0.3 to 0.58 with an average value of 0.51. And here this element shows the performance graph for the selected field, using which the optimum number of zones are obtained as 4. And that's why this is the field of the same image, selected field, which is showing you the 4 zones, 4 optimum zones in different colors. And we have a message element which tells you that the zoning may be useful or not for your selected field. So all these elements are interactive to each other, and it provides flexibility to the users, farmers to select their fields by different available options, which I am going to discuss in detail later on. So now this is the screenshot of the tool, part of the screenshot, which is showing you the map with all the fields of interest highlighted in yellow color. Here, you can use this search icon to locate your field. Here, this is a screenshot showing you all the field details of the selected field. We can get all the field information for our particular field. So now here I am showing you the screenshot of how you can select your field using field Id Selector, which I will discuss soon. So now I would like to go live and to show you and to give you the feel of how it actually looks and how it works. Can you see see the tool?
No, we still can see the slides.
Okay, let me see. Can you see now? No.
I think it's still slides, but you can stop sharing perhaps and then share back again, maybe you close your slides. You just keep the
Oh.
tool open.
Yes. Just give me a minute. Yeah, sorry.
It's fine. I think we see the tool now. I mean, although the field ID is at 200, I don't understand. Is this a screenshot of the tool or tool itself?
I can do it. Yeah. Are you not able to see now?
We see a white screen, half of the screen, and then also the slides on the right half. I would recommend that you stop sharing and just open the tool.
Okay, yeah,
and then
I will
start
do
sharing
that.
again.
Yeah. Okay, I think you can see now.
Yes, perfect.
Okay, yeah. So this is the actual tool VRI-EVAL. Here you can see like we have all the fields of Imperial County. Here we can zoom in. And if we know the location, if we know the location of a particular field, like it's nearby Salton Sea, and then you can simply go. You can simply go to that location. It is working slow, I guess. Yeah. Okay, we can go to home page anytime. We can. So yeah, let me see. If you know the location of your field, like it is around this corner nearby Salton Sea, then you can simply enable this icon and go to that field, zoom in and go to that field. Then you can click on it to select that field. Now you can see the results for that particular field. Like here we have we have random numbers showing you the variability within the field, and optimum zones indicator showing that we have 4 optimum zones for this particular field. And there we have the image. Here we can see like 4 zones. The field is divided into 4 zones, which are presented in different colors: red, yellow, light green, and dark green colors. And here we have different Ndvi values showing you the values for different zones. And here we have message that zoning may be useful. So probably the field is variable. There is a possibility that the results are not the exact reflection of the field condition. So we have to go to the field and validate the results. So now, once you know the field, you can note down or memorize the field ID for this particular field, which is 4110. So next time, whenever you come to this field, you can simply go to the field ID selector to select that particular field. Then you can see the updated results here, like how much variable the field is, what are the optimum number of zones, and how the zones are located and arranged within the field, with the message that whether zoning is useful or not for this field. So, but there is a one thing to note down, that if a field is already selected and you want to use the field ID selector, then you have to deselect it, and you can maybe go to home page. After that, you are free to use field ID selector. Now you can simply select any field ID or enter the field ID if you know, like if it stands random number. I'm just selecting random fields, so you can go to any field. For this field, you can see that there is a message that field is almost uniform and zoning may not be required. So probably the field is not much variable. Here, the variability in Ndvi is not so significant to consider the zoning for this field. So we can move forward according to our message or recommendation. We have navigation instructions are also provided here, which will help you in navigating through the tool. And we have field details element which provides you all the details of the field. And you can enlarge this image if you want to get a closer look of this field, and you can save it, maybe like if you want to analyze it later on, and then you can go back and here you can see all the results. So now let me go back to the slides. Okay, can you see my screen?
We can, but I'm not sure if it's a slide. Yes, it's a slide.
Yeah.
Yes. Okay, good.
Okay. So yeah. Uh, so finally, the take-home messages are that pre-adoption assessment showed that the tool helps in providing key insights for at-a-glance decision-making related to variable rate irrigation, visualizing trends, and monitor activities. This tool is free, interactive, easily adaptable, and very much user-friendly. This is a pre-adoption assessment zoning tool which would help farmers in understanding the variability within the field. It will bring more knowledge to farmers about their fields and enable decision makers to identify the potential zones for variable rate irrigation systems. And we are still in the process of evaluating the tool for the fields using drone and ground truth data. Farming data can also be included. This is actually a useful tool for variable rate irrigation purposes, but have to be used with caution since there could be errors and the results may vary slightly from the actual field condition. So farmers knowledge always comes first and it is most important. So we can go to the field and validate the results before proceeding. So the link for this tool would be available as soon as it is ready to use. Also, we totally rely on feedback. So please provide us the feedback when you use it so that we can improve the tool. We are thankful to USDA and NIFA for providing the funds to support this work. I would also like you to know that we are working on another tool on how irrigation application or how irrigation water availability can impact the crop production. Hopefully, we will be able to present it soon in the next irrigation workshop. Thank you for your time. I really appreciate it. Please feel free to ask or contact us to the given email ID or our lab website. We would be happy to answer them.